Right. Good morning, students. I hope you are fine. I'm so happy to meet you by giving you another lecture or another teaching, that is the concept of Dalton's atomic theory. As we all know, I have been doing series of videos in order to enhance you the learning process regarding the atomic structure lesson. I'm so happy to give you this information. Why? Because my hope and my intention is you have to enrich in the content what you are learning simply. My favorite subject, chemistry. I love to teach chemistry, and my favorite topic is atomic structure. Today, we want to learn a new concept. While learning the series of videos, we are going to learn another one more video that is called as Dalton's theory of atom. Simply, we can say that. While you are learning this video, especially or this class has to be divided into three parts. Number one, personality of Dalton. Number two, historical context behind this theory. Number three, postulations or the content of Dalton's atomic theory. The first one is simply we can say biography. He born in 1766. 1766 means another contemporary scientist, a great scientist, a great eloquent in his speech, none other than Antonio Lavoisier. So John Dalton was a contemporary scientist to Antonio Lavoisier. Antonio Lavoisier was famous to be called as father of the modern chemistry. So Antonio Lavoisier was the father of the modern chemistry, and John Dalton was famous to call him as father of materiology actually. So these two contemporary scientists, they came from different backgrounds. John Dalton came from weaver's family, but Antonio Lavoisier came from very wealthy family. Okay, now moreover, John Dalton and Antonio Lavoisier was simultaneously contemporary the famous one of the greatest scientists called as Humphrey Davy. I love to pronounce his name. Why? Because I'm so overwhelmed when I'm pronouncing his name, at least because of his speech, eloquence, and profound in his the way he expressed, the way he communicate the chemistry, the concept of chemistry before the Royal Society. In the crisis of Royal Society, Humphrey Davy, he did a great job in order to revive that Royal Society in a rich mood. Now, John Dalton, he came from weaver's family, and he worked as a teacher at the age of 12. He has been studying in his home, and he developed a small lab in his house. One room is developed in order to find out the atomic weights. That's the point actually. In those days, that's the only property we have known very well, that is weight of atoms simply. We did not learn, we did not know atomic numbers, electron configuration, all these things. At that time, we have known only the weight of an atom. Simply, we can say atomic weights actually. So, John Dalton, he was working for that research actually. He published a book. That book is called as A New System of Chemical Philosophy. This book is very famous. So, A New System of Chemical Philosophy. In that book, he gave all his, propositions or research or the thoughts what he has been doing, right? After that, he proposed in 1803. He proposed law of multiple proportion, and he explained the partial pressure of gases. Actually, the law of Dalton's partial pressure of gases is also a principle. Based on all observations, he came to give an information, that is, he published, he researched and wrote one book. The book is called as New System of Chemical Philosophy. This is the book which is famous and it's very well known to the chemistry society actually. After that, he became the member of the Royal Society and he was awarded the first Royal Society medal actually. And he was, at the time of his death, thousands of people honored him, respected him, showed their regard and respect by March fasting. That's the greatness of the John Dalton till we know that. So John Dalton's service is very much useful to the Society of Chemistry actually, because he explained the postulations, all the postulations based on his own observations. That is a statement I want to state it because it's very important. Now, go to the next concept is, second part is the historical context. What is the historical context? Before Dalton, there are some scientists. There were some scientists came forward to explain same concept actually. Brian Higgs, his assistant and nephew called as William Higgs, and another scientist from Oxford University named as William Austin. These are the scientists. They had their own research. They had done their own research regarding the formulation of a table to find out the atomic weights of the elements actually. So, as we all know in science, there was a clash between these two scientists. Dalton at one side, and William Austin and Brian Higgs and William Higgins. These three are at one side. Between these two groups, another famous scientist, Humphrey Davy, heard all the disputes and debated issues. They came to conclude one thing. They have their own research. They were unknown to each other. That is the conclusion actually. So that this theory was worldwide accepted. So even though that historically it has a much contextual background, but we must understand his theory was very useful and accepted worldwide, internationally. So now let us go to the concept of Dalton's atomic theory or atomic theory of model. Dalton's atomic model proposed by same scientist called as John Dalton. So I want to give you five propositions. Just I want to give or five postulations. Some of the chemistry faculties are very much interesting to say four postulations. Some of the chemistry faculties, they wanted to divide into parts and to give 6 or 7 or 8 parts. Whatever it may be, mostly 4 properties or 4 postulations are enough to study, or 5 is enough. Just I want to explain these 5 postulations. Now, what is the first postulation he explained? The first statement he explained. The statement number 1, that is, the first postulation is matter is made up of smallest, tiny, indivisible, fundamental particles which are called as atoms. So, what is the meaning of that? Meaning, every matter is made up of atoms. Atom is the ultimate particle of matter. Atom cannot be divided furtherly. This is the statement. Second, actually, is this correct statement? Stand. It was proved to be wrong in further research. They came to do some research. Series of research had been proved this theory in wrong. The reason is, what's the reason for that? Because he proposed it in 1803, he published it in 1808, but that theory became known at the time. But 1895 to 1932, in these years, there is a great research. There was a great research. That research is called as invention of subatomic particles. Atom can be divided under special conditions. Atom can be divided under special conditions. What are the conditions? When we decrease the pressure, when we increase the potential, as a result, we can divide the matter into negative charged particles, positive charged particles, neutral charged particles. Dear students, so that in between 1895 to 1932, in these years, what happened means electron, proton, neutron were discovered. So that we can prove this statement to be wrong. That means Dalton's first statement is wrong because these fundamental particles or subatomic particles were discovered so that atom can be divided furtherly. Atom has approximately 32 particles. That's a fantastic idea actually. Second postulation, atoms of a given element. See, atoms of a given element are identical in mass and in all properties. This is another statement he explained. Atoms of a given element, for example, take hydrogen. So, hydrogen atoms in every time they have their same properties. Take gold. So, in an element there are so many gold atoms. All these gold atoms behaves like same in every aspect. This is the idea. So atoms of same elements behave like same in size, in properties. And second thing, what is the meaning of that? Same elements, that means same atoms of element behaves like same. What is the, is it right or is it proven to be appreciable? But actually it was proved to be wrong, it is incorrect. The reason is, what's the reason behind it? At the time, Sadi, P-S-O-D-Y, Sadi was a scientist. He discovered isotopes. As a result of that discovery or research, what happened is they came to conclude one thing, that is, isotopes are also the atoms of an element which have same atomic number but different in masses. For example, carbon, its atomic number is 6, but its mass numbers are different, 12 and 14. So carbon 6 and 12 and 6 and 14 are the two kinds of atoms of that same element is available. So what happened means, according to the Dalton's theory, atoms of the same elements behave like same means it is not possible in the concept of isotopes. So that Dalton's second postulation was proved to be wrong. And the third point is atoms of the different elements. Atoms of the different elements behave like different. See, atoms of the different elements behave like different in mass and chemical properties or physical properties means, what is that meaning to us? Meaning actually, let us think about it. Different elements behave like different. Stand. Is it true? No. This was proven to be wrong because isobars were discovered. Because of the discovery of the isobars is the atom of isobars. These are the elements. They have their different atomic numbers, but they have same mass number. So atoms of the elements which have different in atomic number and same in mass number, this is called isobar. Even though they are different, but their physical properties are same. So this theory was proved to be wrong. Indestructibility of a matter. That means, fourth postulations. Atoms of a matter are the atoms neither be created nor be destroyed. Atoms neither be created. We cannot create atoms and we cannot destroy the atoms actually. Is it true? What's the meaning actually? Atoms are eternal, atoms are indestructible, atoms are the building blocks of a matter. Is it true? No, this is wrong statement. Why? Because Madame Curie, they came to explain nuclear radiations. Simply we can say nuclear fission and nuclear fusion reactions. As a result of these nuclear reactions, what happened means new atoms are born, new atoms are created. Okay, for example, because of the diffusion of the uranium atom, different atoms are created, regenerated actually, new atoms are born. And because of the decay, like we will study in alpha decay, beta decay, Because of that, because of the decay, what happened means new atoms also formed. So this is also a wrong concept. New atoms also can be generated. Okay. The lost concept is atom is the only one which participate in a chemical reaction. While the atoms are combined, in that combination they must combine with the fixed whole number ratio. Fixed whole number ratio. That means this is dealing about the law of combination and law of constant proportion. As we all know, we've learned three laws of chemical combinations: law of constant proportion, law of multiple proportion, and law of conservation of mass. In that one, definite proportion explained like this: while the combination is taking place, there must be a combination with the proper whole number ratio of mass of the atoms involved. So, this is statement, is it true? For example, in the time inorganic compounds where we have studied so many carbohydrates, C6H12O6 and C12H22O11, all these are the complex organic compounds which do not obey this concept or this law. So as a result, all these five postulations were proven to be wrong actually, but these five important propositions or statements, that the five statements are the pioneering work of Dalton, which helped a lot for further research, for further study, so that only these five are very much important to learn for exam purpose and for the contextual study of chemistry purpose. So dear students, please go through this lesson once again and read it once again. So I want to give all the summary in the lost concept, as a lost concept in my video. At the last part of my video, I will give a summary of the Dalton's theory of atom in one slide. Once you go through this one, and you can learn it and you can share your thoughts and ideas. Thank you so much. God bless you.